Hello, this is Mike at Gamefromscratch, and welcome back to our ongoing Godot Game Engine tutorial series. Today we're going to be taking a look at particle systems. If I sound a little bit different to you today, I apologize for that. I just learned that what happens in Vegas stays in Vegas. Unfortunately, does not apply to the common cold. So I am currently a little bit drugged up, and I'm at that sweet point where I can still form a lucid sentence, but not be crippled by throat pain. So I'm going to rush through this a little bit while I stay at that sweet point. So hopefully I make enough sense while I'm going through this video. So anyways, looping back, we are going to be talking about particle systems. Now, if you're not used to games in the past, a particle system is basically a whole bunch of sprites or system-generated sprites that are controlled by an overarching system. Mostly what that means is it's a whole lot of dots or similar-sized shapes that go together to make a more complicated end structure. A common use of a particle system would be smoke effect, fire, sparks, sometimes fog. But it can also be used for controlling a whole bunch of sprites using one system, something like a flock of birds, which is specifically something we're going to do today. So particle systems are very useful, often for special effects. If you play something like a first-person shooter and there's a muzzle flash, quite often that is implemented as a particle effect. It's hard to tell specifically because some of these things can actually be implemented with shaders or trickery. So sometimes it makes sense to use particles, sometimes it does not. Now, particles are something that are somewhat supported at the GPU level, but can vary in performance from machine to machine. So sometimes it makes all kinds of sense to use particles, sometimes it does not. Also, the fidelity of your particles, the number of particles you use, will really affect the visual approach or the visual look, but it will also add an increased load onto your CPU or GPU. So it is a balancing act. Also, particles are somewhat of an art form. You're basically creating moving art when you're defining your particle system, and it is going to take an artistic eye to get an end result that looks solid. For this version, I'm going to be implementing two different particle systems. One is a simple flame like you'd see from a torch. The other one, as I mentioned earlier, was a flock of birds. Two very extreme examples of what you use a particle system for, but it does show somewhat of the diversity. Now, Godot does make using particles quite simple, so let's jump right on in. I'm going to start off a new project here. Once again, I'm working out of my download folder. Particles. Open and create. And let's load our new project up. Once again, I assume you've gone through all the prior tutorials in the series, so you know everything I'm about to do about project configuration. If you haven't, go back and see them. In addition to this particular tutorial, I've also done a text version. It's already live on Gamefromscratch.com. It's called Part 12, and it's Particles. It also has a link to a very handy reference site over what a lot of these properties are from the Godot wiki itself. So I didn't replicate it. I'm not going to go into a whole lot of detail about all the various parameters you're going to see. So if you go to Gamefromscratch.com, there's a link right away that will show you details of what a lot of these different properties that I don't cover actually do behind the scenes. Alright, so first we're going to need to save our scene. Oops. I guess first we need to set a node. So there's our root, and save our scene, and set our scene active. Like so. Now, Godot is remarkably consistent in how it does things, and this is yet again another example. As you might be able to guess, a particle system is just a 2D node, or another node. There are 2D and 3D specific versions available. Eventually I will start covering the 3D stuff. Let me just go ahead and shut my mail down so we're not inundated with those. And as you guess, it is just a matter of creating the right node, and that is particles 2D. And that node already is pre-configured. You can see it spraying out particles as it goes. We're gonna muck around a bit with what those particular things do. I wouldn't generally this is a position only node, so don't scale it, don't rotate it. I'm not sure what the end results are, but it isn't really a node to be changing the side of the widget isn't going to have much of a profound effect. There is, however, one very critical setting, and that is hiding. And right here, your local space. And this is how the particle will be contained. And so if I turn that off, you'll see the effect. So if I move this particle system around, you see what's happening here. Now if I turn that off, so if you're doing a contrail attached to another, so you're doing the jet of a jet engine and you're moving along with another sprite, this is probably the setting you want. So if you're doing like a stationary flame, you're going to probably want to set local space to on, like so. Notice the weird graphic effect, ignore that for now. So this is a standard particle system, and what I want to do is I just want to go ahead and create a torch, like you would imagine. So picture a sprite right here that would be the handle, and this is the flame coming out. So the first thing you can see we're going to need to do is change the direction that we're spraying. And that is done in degrees with the parameter. So you got over here, we got your config, which configures the overall. Actually, I'm not really sure why config and params are split up. But the parameters you want to set right here, we just go, we want to rotate 180 degrees. So this is in degrees. And now you'll see our particle system instantly updates. So it's going up and down like so. So if you wanted to go 90 degrees instead, predictably enough, the result will be to the right, and 270 degrees would be to the left. So like I said, we want to go straight up and down like so. Let me zoom in on this guy. You'll see something. See how it's cascading down? Well, that's because gravity is taking a hold. And it'd be more profound if I actually let this lifespan be a little bit longer. And this is actually a very key value to how particle systems work. This is the total number of particles that are going to exist across the span of the system. So in 2 seconds' time, 32 particles are released. And those two values are going to go together by default to determine the rate that they're released at. But after those 2 seconds goes, so after a particle starts here, it goes this way for 2 seconds and then dies. So you have this constant flow of 32 particles across, or 16 particles per second. And these go together to determine. There are other things that are going to, if you want to change the scale or the way those things happen, you could do that using this time scale value here, or you can do it with dampening, which determines how fastly the particles fade off at their end. But I'm going to keep it this one. Actually, the 2 seconds actually works pretty well for us. And we might tweak this number right here, the amount of particles we do. But we want our particles to be constantly streamed. Otherwise, you can use this value. You can change this up a bit, and it changes the way that the particles are distributed. So if you see explosiveness is set to 0, they all explode out at once. Whereas we can go midpoint, and you get a bit of a slower dispersal, but again, not a constant stream. And then we'll go back to 1. And you'll see this constant stream. This is what this is effect you would ultimately want for a torch or a flame look. But do be aware that when you change and muck with these values, especially time scaling and lifetime, it will have an effect on all of the other parameters. So you might have to jack your numbers up for things like frame rates, etc. We'll see later on. Okay, so the next thing you'll see is this cascading off like this. And if I turn the timeline up, it's more pronounced. So you see, they're actually being pulled back down, and that's because gravity is being applied to this particle system, and we don't want that. So first off, I do like the 2 second rate, but I do not like it cascading like this, and that's going to be a matter if we just come down here and we take gravity, and instead of a 9.8, and nice thing with Godot, most of these units are either pixels, as in screen pixels or whatever, or they're in degrees. So 9.8 pixels per second of gravity, and we're just going to turn that into 0. So now we don't fall at all. Now what you will notice though is we're going a little excessively in our flow, and that is controlled by linear velocity. And we're going to turn that one down a little bit to about, say, 15. Yeah, that'll work. And our spread, this is the degrees that it's fanning out this way. Yeah, I'm actually okay with what we've got. Okay, so this is starting to get a little bit more torch-like, but in all honesty, looks absolutely nothing like a flame yet. And the easiest way we're going to move to the next step is on colors. And that can be done by specifying color phases. And the very first one is your very first color. So by default, we have one color phase, and it's white. And we're actually going to keep white, because if you look at a flame, the most intense point generally is white, then orange, then red. So we're just going to add those other two. So we need to have 3 color phases, like so. You can immediately see the effect. So that's a white to blacker transition that we've got going. So now we want to just change each one of these values. Orange RGB value is FF3300-ish, I think. That's a little too There we go. So as you saw, you could specify using HTML style color codes, or you can just use the sliders here. And then there's also the alpha channel. And we actually want to make this one a little bit more transparent as it gets away. And then our final color here is red. And I want to decrease the alpha even, oh no, yeah, alpha down on that. And that position is 2. Why are you not? There we go. So we've got our colors transitioning between, so from our beginning point, midpoint, end point. Actually, you know what? I want my white to be white a little bit longer. So we'll make this one like that. Okay. So now we're looking slightly more flame-like. Next thing we're going to do is figure out our size. So we're going to start off with our particles being a little bit bigger as we start, and then we're going to get smaller as we go. And that is done by these 2 values right here. Now be careful here. You've got a set of values here, and it's going to look like you can't set them. That's because these are the randomness values. These are the values that you change from particle to particle to add some randomness to the results. So this is basically saying how much these values can vary by. But what you actually want to set is the param values, at least initially, unless you're trying to do a variance between the particles themselves. And what we're going to do is set our initial size to 3, and our final size to 0.5. And now you can see it's definitely more flamish. I'm gonna jack the spread down slightly. Let's go to 5. And our velocity is fine. There you go. In my opinion, that's actually a fairly passable flame being generated dynamically. Now the thing is, this is actually used generated. It's using generated sprites, basically. It's making rectangle sprites, and then we're setting the size of them right there. And you notice that they're square, and that may not be ideal. You can obviously tell that they're square here. What you could have done is you could have created a texture that was round and just used it instead. You could just create a simple white circle, small circle, and use that as the texture. We'll see how to use textures in a moment. The other thing you can do, and again, here's a trade-off. Do we want it to look better, or do we want it to run fast? What you could also do here then is change your size down. Let's go down to 2, say. Actually, even closer. Down to 1. And we'll change this guy to, say, 0.2. And then up here, add more particles. And see, you're going to get a better result for sure. It looks more realistic, but it's got a higher performance cost. And again, it's all going to be a trade-off. What you want to, the amount of processing power you can dedicate to what you're doing versus the graphic fidelity you want. But as you make the particle smaller, you'll see this is a much more realistic effect. Now, like I said, there's a bunch of options in here. You can add a little bit of randomness between your particular particles. You can change the way that they rotate, the amount of gravity's effect on it, radial rotation, etc. Like I said, if you go to the link off of Gamefromscratch, it's got an illustration of almost all of these things in effect. So I would suggest going there. One other thing you can do on this particular guy, beyond what we've done, is you could layer another particle system on top of it. So say, for example, you wanted to add smoke. It can be as simple as, either as a child or on top, just create another particle system, and we can go somewhat through the same process. But what we want to do is say, let's make 64 of these guys. We will turn gravity off again. We will go in the same direction, like so. We need to slow them down a bit. We're using 15 out of 154. There we go. And finally, I suppose we can set the color. So we want 1, and the color will be gray, a good opacity like so. And there you see, we got like a smoke effect going on top. Down the opacity even more. There. So now you've layered on another particle system on top, and you're creating a smoke to go along with your underlying flame. Again, the more detail, the more you add, the more realistic it'll look, but at the same time, you are going to jack up the processing power cost. But here you go. If we had a graphic right here of a torch, this would be a fairly convincing flame effect for a few minutes of work. That is basically how a particle system works. Now, as I told you earlier, you could actually use an image, and that's what we're going to do next. We're going to actually use a series of images to show an animated bird as our particle. Let me just go ahead and scrap everything. So we'll create the exact same process. It's still a particles 2D. Let me zoom out. So let's move this guy, and we're going to go to the left instead. So 270. We're also going to create a few less of them. So let's go with, say, 16 instead. And they are going to live a lot longer. Like so. And birds don't, well, they do get gravity applied, but generally not in this case. So there we go. Just this constant stream out going this way. We'll do a bit more spread. So let's start with a bit more. 24. And then one other thing we didn't really talk about earlier is if you've got something exactly like our torch, actually, when you first enter the scene, the particle system is going to start up, and that's not going to be what you want. You're going to want the particle system from very beginning to be a flame. And if that's the case, what you can use here is this pre-process value. And this is to say, run this particle system for this amount of time immediately. That way, when your particle system starts, it's pre-computed for a whole bunch of, so 2 seconds worth of particle processing would have already handled. And that's what this process right here does. Okay, so there is our particle system emitting our birds. Now we just need our birds. And that is a matter of we need a texture. And I already have one. Here it is. Now this is a limitation. I don't know if Godot has it or not, but this is a square texture. There are an equal number of rows, and it doesn't need to be an equal number, but the bottom row needs to be full. And I don't know a way around this, to be honest. There's no way to specify the total number of particles in your total number of sprites in your sprite sheet that I can see here. So it may be a limitation that you actually have to use a sprite sheet that's in a grid, so that's got an equal number of rows as columns. Again, there might be a way to get around this, but I don't know what it is. But now let's go ahead. We'll use that texture. So first of all, let's go ahead and import it. Another thing is that texture is very big. So we're going to be scaling down our particles. You would probably actually scale down your texture if you were a much smarter creature than me. And bring it into the game, choose, and import. Okay, so now what we're going to do is set that as a texture atlas. So create a new atlas, load it, use our newly cropped texture, and not quite what we want, but we're getting there. Now what you're seeing is a texture sheet of 16 different Robin images all being shown at once. So what we have to do is narrow it down here by the number of rows and columns we've got. Let me bring that texture back up. So as you can see, I've got 1, 2, 3, 4, 5 columns, rows. I always get that mixed up. And then 4. So what we need to do is come back here and set 5. Oops. 5, enter. And 4, enter. And now we have individual birds. Very cool. Now what I told you earlier is those files are very, very big. I think each frame's about 350 pixels. So that's why you're seeing what you're seeing now. So all we need to do is come on down here and set the size, initial size to about a 1/10. Now the key thing is we're going to want to set the final size too, because as you can see, our birds are growing constantly over their lifespan. That's obviously not ideal. So there you go. We now have a flock of birds. Now, what you may notice is our wing speed sucks. And this is determined by your animation speed here. And this is how fast you'll go through each particular frame of animation. So let's go through 10. Now you see a much better flowing animation of our flock of birds. Because they're being emitted over time, you're not seeing that if they were emitted all at once, and I can probably do this right here by using explosiveness. All right, so we got to wait for that. See, now That's not ideal because every single one of these birds is basically in lockstep, right? So you've got your particles that are identical. And this is where your randomness comes in. So in randomness, what we could do is go and set uh, one of these values to, say, I think 2. There. So now we have, I guess this is actually a 0 to 1 value, so 0.3. Wait for the next explosion. So now you see the wing speeds are not all the same. They can also start them off on a different frame. So next explosion. And there you go. Now they look all a little bit different. We can also change the spread. All right, they're all 0 to 1s. Okay, so 0. That 0.5. And it will randomize the amount that they're spread out by. I guess that will have no effect on this system. But anyway, so that's what these particular values are for. The amount of variance between the individual instance of the particle and the system itself. And the biggest thing I wanted to show you for is so that the flight patterns are different, so the wings are different. It's not going to be so obvious, as I said, if I wasn't using this explosiveness value, because all of our birds were actually created over a span of time anyways. It will have a bit of an effect. It will make it look a little bit more natural, a little bit more organic, having them so they don't always start at the exact same point. But there you go. There are 2 different particle systems. The first one, like I said, it showed a nice, easy, relatively CPU-friendly or GPU-friendly firework effect or flame effect. And here you can see a particle system also being used to generate birds. And again, as you move the system around, all of the created particles are affected by that. Whereas if we go back here and turn local space off, it just moves the spawn point, and then all the corresponding particles released after come from that position, like so. So that's essentially it. That is particles in Godot engine. Now you'll find there's no programming in this particular example because realistically, your entire programming interface, and I'll show you this quickly. Particle 2D. Alright, I'll just scroll down and find the damn thing. Particle 2Ds. There. It's just get and set methods for each of the values you see over here. So you can create one of these programmatically if you want, but these are literally just get and sets for here. Now, what you'll notice, though, a lot of them will take a param to set, so get randomness for this parameter, and then your parameters are defined here. So you would pass in param underscore initial size or final size. In your get call and in your set call, same thing, just with the value being passed after. But otherwise, it's basically just the exact same stuff you can set over here being set over here. So not a big deal. But again, it is a node too, so any of the node-related stuff for positioning, etc., can all be applied without issue. And I suppose there is one other thing I should show you. And we'll make a child of this particle systems 2D. The other particle effect here is the attractor. And this is like a virtual black hole. Basically, it will suck things within its radius in, and then what it does with them is up to you. And I will show you now there. So everything comes in, it gets sucked in and spit out. Now the alternative is we could set this to, instead of spitting them out, absorb. And we'll put the absorption strength at really high. And you'll see it's just sucking them in. So if for some reason you needed to catch all the particles going in a certain direction or a certain way, or you have an effect that basically is arcing between 2 points, your particle attractor 2D is useful for implementing those. And it's this absorption factor right here that determines if it's going to be sucked in or not. You can also change the radius like so. And what else would be a matter? That's kind of basically it, to be honest. So very handy thing. That's about it. So that is particles in Godot engine. I hope you enjoyed that. Thank you for your time.